Nope. Okay, so we have line 22, 7b97z91, BEC Magneto Optical Traps Dipole Orthogonal Beam Collisions 87RB 5G Wow Seti. This is the alien radio signal, and that's the date there. So, all-optical 87RB Bose-Einstein condensate experiment, Magneto Optical Trap MOT. Previous video was line 22, 7b97z90, scanning beam trap, BEC Superfluidity, laser light atom frequencies 5G Wow Seti. So Google atomic pulse equations, and close in PDF file. Results are on a blog. Optical dipole force on ladder-like 3-level atomic systems driven by chirped fused cycle pulse laser fields. There's the name of our scientist there, and that's June 2012, arxiv.org. The keyword optical dipole force plus scanning bead trap. Keyword is all-optical BEC experiment, and quote from blog. All optical traps for BEC4 have many advantages over those of conventional magnetic trap geometries, including simplicity of the setup and sensitivity to the spin state and the high BEC production rate. Furthermore, evaporative cooling is achieved by simply reducing the intensity of the trapping dipole beams. We've built a second setup to produce an all-optical 87RB Bose-Einstein condensate experiment. Our system starts with standard Magneto Optical Trap MOT, loaded in our vacuum chamber from a rubidium dispenser. After a compression and optical molasses stage, the atoms are loaded into a single beam dipole trap overlapping the MOT, formed by a laser operating at 1064 nm with a beam waist of 27 ohm and a power of 14 W. Our initial conditions in the single dipole trap are 3 by 106 atoms with a temperature of 250 UK. Our first stage of evaporative cooling is performed by lowering the trapping intensity in the single beam. A secondary orthogonal beam is then ramped up in power, compressing the cloud and increasing the collision rate before both beams are lowered in intensity. So Figure 5, all-optical BEC setup. And Figure 6 is the absorption images of 87RB loaded into the single beam and cross beam dipole traps. That's from physics.uq.edu.au. And we're going to continue with the keyword atomic pulse equations in the next videos. Thanks for watching.